Welcome to the Walton Pi. Today we're going to be talking about Borel sigma-algebras and separability. So we say that a space is separable if it has a countable dense subset, and then a separable metric space we call a second countable space. Some examples of separable spaces are the following. A topological space with countably many points. The space R with the standard topology. One countable dense subset of R is the set of all rational numbers Q. That's going to be a countable dense subset. And then note that R is also going to be a metric space under this topology, so this is also an example of a second countable space. So now let's talk about a proposition. Let's let x1 through xn be metric spaces, and we're going to let x be the product of these metric spaces with the product metric. Then the product of our Borel sigma-algebras over each xi, that's going to be contained in the Borel sigma-algebra over x. And if each of those xi's are separable, we actually end up with equality. So let's go through the proof. So by a proposition in the previous video, the product over the Borel sigma-algebras of xi is generated by the set of pre-images of open sets in our xi's, because the collection of open sets, that is going to be an elementary family. Since the projection map from x to xi is continuous, pi I of e is going to be open for every open e in x. So that tells us that the pre-image of our open sets is going to be a subset of all open sets on our big set X. That tells us that the product of the Borel sigma-algebras on xi's is going to be generated by the pre-images of open sets, which is going to be a subset of the Borel sets, or the Borel sigma-algebra on X. A fact from topology is that if each xi is separable, so too is the product of those separable spaces. So further, every open subset of X, we can write that as a countable union of open subsets of the form CQX, or a cube of side length 2Q, so Q is a length and the side length is 2Q, and then X is just going to be the center, where Q is going to be a positive rational number, and X is just an element of the countable dense subset of X. So we're saying, okay, go to the countable dense subset of X, go to one of those points, and draw a little cube around it where it's 2Q in each direction. So that way we are guaranteed to hit every single point. Okay, so that tells us that the Borel sigma-algebra on X is going to be a subset of the sigma-algebra generated by the product of open sets, because those cubes are exactly some of those products of open sets. And that's a subset of the product of our Borel sigma-algebras on each xi, which is going to be a subset of Borel sigma-algebra on x, so we have equality in the separable case. As a quick corollary, this tells us that the Borel sigma-algebra on Rn is the product of the Borel sigma-algebra on just R. Okay, so since R is separable, the previous proposition is an equality. There we go. That's the entirety of this corollary. It's a very helpful one, and this is what we actually use most of the time. But this is a helpful fact in analysis. I hope this video was helpful. If it was, please like and subscribe. Leave comments down below of other topics you would like me to make a video on. And I hope you have a great rest of your day, and good luck with all of your math.